Alright, in this video I'm going to analyze factored polynomials part 2. So I'm going to talk about where it's positive, where it's negative, graphing them, and other things about polynomials. So the first thing that I want to talk about is where a function is positive and where it is negative. So I have a graph here, and my question here says label where the function is positive and where it is negative. A function is positive when the y value is positive. So I would be positive here for this piece, and I would be positive here. I would be negative when I'm below the x-axis, when my y value is negative. So this is negative, this is negative. Okay, so the next question says f of x has the zeros -1, 2, and -3. So right away I can plot -1, 2, and -3 on my graph, because those are my zeros and that's where they cross the x-axis. They tell you that f of 1 is a negative value, so that means that when x is 1, y is negative. I don't know, I just made it -1 just as an example. We don't know it's -1, but it's negative something. And then f of -2 is a positive number, so when x is -2, we know we have a positive y value. Okay, so I'm going to put on my graph, when x is 1, I know that it's negative, so I'm going to be below the x-axis at 1. I also know at -2, I'm positive, so I'm going to be above the x-axis at 2. And all I'm going to do is go through these points and sketch a possible graph of f of x with what they gave me. The next question says, given f of x, state the degree, the number of x-intercepts, and the number of max and mins. Well, the degree all depends on how many factors we have. We have 1, 2, 3. The 1/2 is just a coefficient in front of the polynomial. There's no x attached to it, so it doesn't really mean anything besides the fact that it changes the shape of the graph. It's either a vertical stretch or a shrink, so it makes the graph taller or shorter. Now, the number of x-intercepts that I see on my graph is 3, which matches the degree. And the number of max and mins, that's a max here, and that's a max here. There are 2 in total. So what I can notice here is that my number of max and mins are 1 less than my degree, and 1 less than my number of x-intercepts. So that being said, with the last slide, says what is the minimum possible degree of the polynomials graph below? Well, analyzing the number of max and mins of the first one, I see I have 1, 2, 3, 4 max and mins. If I add 1, I'll get the lowest possible degree. So the lowest possible degree is 5. Now another way you can do is analyze the x-intercepts. There are 1, 2, 3, 4, 5, so that makes sense. The next one doesn't make as much sense because if you notice, there are 3 max and mins. That means my degree would be 1 more, so it would be 4. But the trick of counting the x-intercepts doesn't work because I only have 2 x-intercepts, but that does not match 4. So the trick that you can do is move the x-axis up so that it goes through majority of the x-intercepts. Well, it would go through as many horizontal crossings that it can. So like it'll cross here, 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 and here. And that makes sense now because it's 1, 2, 3, 4 crossings. So that's why your degree is 4.